Okay, so I'll be going over problem 2 from 2024's Bronze January contest called Cannonball. So Bessie has mastered the art of turning into a cannonball and bouncing along a number line. The locations are numbered 1 all the way till n, starting from left to right. She starts at some integer location s and bounces to the right with a starting power of 1. If Bessie has a power of k, her next bounce will be at a distance k forward from her current location. Every integer is either a target or a jump pad, and each target and jump pad has an integer value within the range 0 all the way till n, inclusive. A jump pad with the value v increases Bessie's power by v and reverses her direction. A target with the value of v will be broken if landed on with the power of at least v. Landing on a target doesn't change Bessie's power or direction, and a target that is broken will remain broken. Bessie can still bounce on it if it's broken. And so she also doesn't change her power or direction. If Bessie bounces for an infinite amount of time or until she leaves the number line, how many targets will she break? If Bessie starts on a target that she can break, she will immediately do so, and also if she starts on a jumping pad, the pad's effects will be applied before her first jump. Okay, so the first line of input contains n and s, where n is the length of the number line and s is her starting location. The next n lines describes the locations. The ith of these lines will contain integers q sub I and v sub I, where if q sub I is equal to 0, the location I is a jump pad, and if it's equal to 1, the location is a target. V sub I is the value of location I. So let's just take a look at this test case. We can see that there are 5 numbers, so the number line's 1, 2, 3, 4, 5, and she starts at location 2, right here. Let's just draw out the number line. So if there are 5 numbers, 1, 2, 3, 4, 5. Okay. Let's see. 0, 1, 1, 0, 1. 0 means that the location I is a jump pad. So we have a jump pad here, we have a target here, and what was it? A jump pad and a target. A jump pad and a target. Okay. So the values are going to be 1, 1, 2, 1, 1. 1, 1, 2, 1, 1. Now this is Q, and this is V. Okay, so what can we do from here? We know that the starting location is 2, so we start right here in this place. So Bessie starts here. So right off the bat, we can see that this is a target, and since Bessie's initial power, like I said in the problem statement, is 1, we only need 1 power in order to break it, and we have that. So this immediately gets broken. So now answer goes from 0 to 1 because we already broke a target, and we have to count the number of targets that will be broken. Okay, she then bounces to coordinate 3 because we have a power of 1, and then we need to go bounce. So we go over here. Over here we see that it's another target, but it has a value of 2. So we can do another bounce. Over here we have a jump pad, and then we reverse our direction because it's a jump pad. And remember, jump pads are when q sub I is equal to 0, like this, and we add a power of 1. So now power is equal to 2, and we change directions. So 1, 2, we go all the way back here. From here, since we already broke it, we can keep going past it. And so we'll get that the total answer is 1. Yeah, so that's how it works. We can see that n is 10 to the 5th. And honestly, I think the best way to approach this problem would just be to simulate it. And so that's what I did. All I did was do a simulation. So I started where they told me to start. So I started at integer s. From there, if q sub I was a 1, I checked if I could break it. If so, I added 1 to the answer count. Otherwise, I changed the direction and also incremented the power. So I'm just going to show the code and then kind of go over the code step by step and see if that helps. Okay, this was the code that I submitted and got full score on. So first I have to initialize n and s and all the other variables needed. Over here, what I did was I created a variable called power, initialized it to 1, a variable that counted the answer, I set it to 0, a direction variable, set it to 1, and so this direction variable, it's either 1 or -1. 1 indicates that Bessie is traveling to the right, and -1 indicates that it's traveling to the left. And I'll show you more later. Position is the current position that I'm at, and that constantly changes because of simulation. And if you guys don't already know, simulation is essentially just kind of simulating the process in order to find the answer. So over here is where I finally start the simulation. So the conditions for this while loop are if position is within the bounds. That's literally it. Over here, I'll explain why I added that in a second, but first let me just go over the logic. So if Q of the position, which means all I'm doing is checking if it's a jump pad, then I add power, or I add V sub position to power, meaning that I take the value at the current position and I add it to power. That's it. And I change the direction. So either 1 goes to -1 or -1 goes to +1. Either way, the direction must change whenever I'm at a jump pad. Otherwise, this whole thing runs if I'm at a target. So if I'm at a target, all I'm doing is I'm setting the fact that I visited it. So viz is just a visited array to make sure that I don't recount the answer. Recounting the answer is bad because we have to calculate the total number of targets broken. If a target is already broken, we don't want to recount it. That's why we keep track of what we visited. And if we haven't visited it yet, then we can definitely run this. Otherwise, we want to skip it. The next condition that must be true is that the value at the current position that we're at must be less than or equal to power. So power must be at least the value of the position. And that makes sense because that was one of the rules that the problem statement gave us. So if all of these are true, then what we can do is we can say that we have visited this position. So we set it to 1. 1 means that we visited it, and 0 means we haven't. And then after that, we can add 1 to the answer. At the very end of this while loop, all we do is we change the position we're at by adding direction, so it's either a -1 or +1, times power. And power is how far we move. So if power is 5, we want to know if we move 5 to the right or 5 to the left, and direction determines that. Next, we add 1 to count. So without the count, I was getting a time limit exceeded on a couple of the test cases. I think it was only about 3 or 4 test cases. And I realized that my code was getting stuck somewhere, but I didn't know where. And so I implemented a very lazy method to kind of fix that. In hindsight, if I had extra time, what I would have done was kind of go back and try to find where the bug occurred and where it kind of stalled my program. Or I could have done it a more smart way because this is not really reliable. But all I'm doing is I set a count variable and then I incremented count after every iteration. If count got too high, I wanted to make sure that I stopped the while loop and printed the answer, because this was just kind of a failsafe to make sure that count never exceeded too high of a limit. And this is about where I would get a time limit exceeded. So if you have any questions, feel free to leave a comment. And if you found this video helpful, please like, please subscribe. And yeah, thank you.